Good morning, folks. How's it going? This is Mike coming back at you with yet another live recording of our college algebra videos. Again, I'm providing some audio commentary on a video that when I first uploaded it, I thought it had audio, but apparently it did not. In this video, we are going to talk about some other types of equations that we will encounter in this course. They're not as common as some of the other ones, but we will encounter them. Polynomial equations, these ones are actually fairly common. We'll be seeing these a good amount in this course. Then radical equations, rational equations, we're going to see a fair number of those as well, and then absolute value equations as well. But first up, polynomial equations. As I said, fairly common type of thing that we'll see in certain parts of this course, in some parts not so much. So polynomial equations are things where we have x raised to various powers, going just beyond quadratics, just going beyond x squareds here, like x cubed, x to the fourth, x to the fifth, so on and so forth. And how we solve those guys is we're going to factor that thing. We're going to set each factor equal to 0, and then we're going to solve for all of the values. So here is a sample problem here. 3x cubed plus 2x squared minus 12x minus 8 is equal to 0. And for the types of polynomial equations that you're going to see from me, it's not the most obvious thing, but what you want to do is you want to sort of regroup things so that if you take two terms in the polynomial and you form each of those to be their own group, if we pull something out of each group so that what's left over in each of those things is the same thing, then that's sort of a sneaky kind of backdoor way almost of having to factor it. So I look at this 3x cubed minus 12x. I can pull a 3x out of both terms, and I'm left with x squared minus 4. I look at the 2x squared minus 8. I can pull a 2 out of both terms, and I'm left with x squared minus 4. Hey, that's perfect. I factored something out of each of those two groups, and I got left with the same thing. So now I can pull this x squared minus 4 out of each of these two terms here, and I'm left with 3x plus 2 times x squared minus 4. And this is a lot easier to factor now. Now you just have to factor the x squared minus 4, but that shouldn't be much trouble for us. That breaks down into the factors x minus 2 times x plus 2. So we have 3x plus 2, times x minus 2 times x plus 2 is equal to 0. You set each of those three factors equal to 0 and solve for x, and you come up with 3x values. You're going to come up with a negative 2, a negative 2/3, and then a positive 2 as well. That's using that zero product property that we talked about earlier on in the course. If the product of two or more factors is equal to 0, then that means that either factor can equal 0. So as you can see, there we come up with our values. Negative 2, negative 2/3, and positive 2. Slide that out of your way so it's not getting in the way of the problems. Here's another polynomial equation. X to the fifth equals 7x to the fourth plus 30x cubed. And what I would recommend, once again, pardon me, is that move terms all to one side so that the term that has highest power of x has a leading has a number in front of it that's positive. The number in front of that highest power of x, that's referred to as the leading coefficient. So move terms to one side so that the number in front of the term with highest power of x is positive. So I'm going to subtract the 7x to the fourth and the 30x cubed from each side to give me x to the fifth minus 7x to the fourth minus 30x cubed is equal to 0. I can pull a factor of x cubed out of each of those three terms. So that gives me x cubed times x squared minus 7x minus 30. And this is a lot friendlier now. The x cubed we can't really factor anymore, but the x squared minus 7x minus 30 we can. And we can use some basic factoring to figure out what factors that will break down into. We need two numbers that multiply out to negative 30 and add up to negative 7, and those are negative 10 and positive 3. So we get x cubed times x minus 10 times x plus 3 is equal to 0. Again, I have the product of three factors that equal 0. If the product of three things is equal to 0, any one of those things can equal 0. So set each of those three things equal to 0 and solve for x. Set x plus 3 equal to 0 and solve for x, you get negative 3. Set x minus 10 equal to 0 and solve for x, you get 10. Set x cubed equal to 0. You take the cube root of both sides and you get x is equal to 0. So there you go. There are your three solutions, 0, 10, and negative 3. This problem, obviously not as bad as the previous one. The previous problem and problems like it, you do kind of have to do a little bit of searching and playing with pulling some things out of each of your two groups. So that is a little bit more of a challenge, but overall, not too bad in the world of solving polynomial equations. Next up, we're going to talk about rational equations. We saw some rational equations earlier. We saw linear rational equations, things where we just had like single powers, the things where we just had powers of x being 1 or things being constants. Well, now we're going to involve things with like x squareds, x cubes, things like that. And we're still just using the same method as we used to solve the linear rational equations. We're going to find a common multiple between the bottoms of all of the fractions involved. You're going to multiply on the top and, you will multiply on just the top of both sides by that common multiple, and then you're going to cancel things out, multiply things in, combine terms, and then you'd be solving a polynomial equation. So here's a sample problem. 3x over x minus 5 equals 2 over x plus 1 plus 2x squared plus 40 over x squared minus 4x minus 5. So we need a common multiple between x minus 5, x plus 1, and x squared minus 4x minus 5. I need something so that if I multiply on both sides by, it will essentially cancel out the bottoms of those three fractions. Well, note that x minus 5 times x plus 1 does give you x squared minus 4x minus 5. So typically we would take just the product of these three things, But since these two things multiplied give us that, we can just take the product of these two things as our common multiple. So that's exactly what I'm going to do. I'm going to multiply both sides of my equation by just the x minus 5 times the x plus 1. And that's going to cancel everything out. Now, you could multiply both sides by the product of these three things, and things would still cancel out, and you could still solve it. So if you wanted to stick with just taking the product of these three things and multiplying both sides by that, that would still work. You would just get some more complicated polynomials afterwards, and it might be a bit less fun to solve it from there. So whichever way you want to do it, that's fine. So here, x minus 5 times the x minus 5 on the bottom, those cancel out. Here, this product goes into this term, the x plus 1's cancel out, and when this gets multiplied into our third term, the product of these things cancel out with the bottom of that fraction that we had. So we have 3x times x plus 1 equals 2 times x minus 5 plus 2x squared plus 40. We're going to multiply things in. 3x squared plus 3x equals 2x squared plus 2x. And then we have the 2 times the negative 5, which is negative 10, plus 40, which gives me 30. Okay, again, let's move things onto one side so that the term containing highest power of x has a number in front of it that is positive. So I'm going to subtract the 2x squared from both sides, and then that also means I'm going to subtract the 2x and subtract the 30 from both sides as well. And when I do that, I'm going to get x squared plus x minus 30 is equal to 0. So I need two numbers that will multiply out to negative 30 and will add up to a positive 1. Going through the mental list of factors of a negative 30, hopefully you came to positive 6 and negative 5. So if we have x plus 6 times x minus 5, that is going to give us what we want. That product equals 0. Set each of those two factors equal to 0 and solve for x, and you get x equals negative 6 and x equals positive 5. So there are our two solutions for this rational equation. Again, you saw that we used the exact same method as we did earlier on in the course to solve those linear rational equations, but in this case, what we had left over after we canceled out the bottoms of our fractions, it had things squared, things cubed, higher things than that. This is a very interesting problem here. And actually, before I go on to that, it's very important to, when you come up with solutions to your given rational equation, you always have to be sure to check your answer. If there are any answers that will make what's in the bottom of one of your fractions equal to 0, then that solution is not valid. We came up with two solutions of negative 6 and positive 5. Well, if I take positive 5 and I substitute it in for x in this equation, I'm going to get some fractions that have 0 on the bottom. So that's not good. We can't have that. What that means is that x equals 5 is not a valid solution to this given rational equation. you have to take each of your x values, substitute them back into the problem as given, and then see if any of your x values, when you plug them in, makes the bottom equal to 0. If it does, you have to throw that x value out, and it is not a valid answer. X equals -6, however, is valid. If you take -6 and plug it in, you don't get any zeros on the bottoms, so you are good there. So we actually only have one solution here of x equals a -6. So I almost forgot to mention that. That would not have been good. That would have been very, very bad. So yes, check your answers after, substitute them back in. If you get zeros on the bottoms of any of your fractions, that solution is not valid. So here we have another such problem, another rational equation here. 1 minus 13 over y equals -42 over y squared. You can look at that 1 in front as really being a fraction. The bottom of it is just being 1. So I'm going to let you try this guy on your own. Try to use this method that we just used in our previous problem to solve this particular rational equation. Find a common multiple between the bottoms of those three fractions, multiply both sides by that common multiple. Actually, we'll just go right through it. Why the heck not? So a common multiple of 1y and y squared is y cubed. So I multiplied both sides of this equation by y cubed. Multiply the y cubed into each term here. We get y cubed minus 13y squared. A y cancels out. And then here y cubed over y squared is just y. So that's equal to -42y. I added the 42y onto both sides to give me y cubed minus 13y squared plus 42y is equal to 0. So now we have to factor this thing here. I notice that each one of these three terms contains a common factor of y, so I can pull that guy out. And that gives me y times y squared minus 13y plus 42. Y squared minus 13y plus 42 does break down into two nice factors, y minus 6 times y minus 7. We now have the product of three factors being equal to 0. So set each of these factors equal to 0 individually and solve for y. And when you do that, you get three values. You get y is equal to 0, y is equal to positive 6, and y is equal to a positive 7. So there's our three values. Now, don't do what we almost did from the previous problem, was we almost forgot to check our answers and see if there were any solutions that actually were not valid. So take each of these y values, substitute into your problem as given, and see if any of those y values give us zeros on the bottoms of our fractions. Well, there is one y value that does, and it's y equals 0. So since y equals 0 makes the bottoms of two of our fractions equal to 0, we have to throw that guy out. That guy is not a valid answer. So we actually only have two answers here, positive 6 and positive 7. I know some of you out there may have been worrying when it came to our previous question. You may have been saying, hey, Mike, wait a second. What happened to checking our answers? We all make mistakes, guys. If you said that, I was testing you. Well done. Gold star for you. So yes, checking your answers is always very important. Next up, now we're getting into the two types of equations that aren't as commonly seen, but we'll show you some examples of what they look like in this video. Next up, radical equations. Equations involving square roots of things, even just square roots of x or square roots of longer things like square roots of polynomials, things like that. To solve equations of the form the nth root of something equals something, you're going to do the following. You're going to start off by raising both sides to the nth power. And we're going to use the property, going back to the first week, that the nth root of a, that whole thing raised to the nth power, is just going to be a. We have a to the 1 over n to the n, and those powers multiply, and you get n over n, or 1. You're going to expand that right-hand side, and then you're going to simplify terms, combine terms, things like that. You're going to move all the terms onto one side of your resulting equation, and then you are going to solve them. And then you're also going to check your answers. Make sure that whatever is an answer, it doesn't make what's inside of your root of an even index less than 0. So as you can see here, check your answers. If you have a root of even index and your answer makes what's inside of your root negative, then it is not a valid solution. We can't take a root of even index of a number that is negative. So here's a nice, easy, basic problem just to start off with. The square root of 3x plus 40 is equal to x. I'm going to kick things off by squaring both sides. And squaring both sides is going to undo that square root that we have on our left-hand side. So you see that's what I did right here. The square root of 3x plus 40, that quantity squared, is equal to x squared. Or just x squared equals 3x plus 40. Again, keep the number in front of your term with highest power of x positive. So to do that, subtract 3x and subtract 40 from both sides. I need two numbers that will multiply out to a negative 40 and add up to a negative 3. And we can accomplish that with a negative 8 and a positive 5. So we have our factors, x minus 8 times x plus 5 equals 0. We come up with our two x values of negative 5 and positive 8. Now, we take each of these answers, we substitute them back into the problem as given, and make sure that if it makes what's inside of our square root negative, then we have to throw that guy out. Well, if you take negative 5 and plug it in for x, what's inside of our square root is still positive, so that's fine. If you take x equals 8 and substitute it in for x, what's inside of our square root is still positive, so that is still fine. So these are two valid answers, x equals negative 5 and x equals positive 8. We just did one such sample of those radical equations. Again, not really a big thing that you'll be seeing in this course, but at least seeing something like it, not bad. Solving absolute value equations or absolute equations really comes down to using this one basic property. To say that the absolute value of A is equal to B means that either A is equal to B or minus A is equal to B. as a bit of a refresher, the absolute value of a is really just how far a is from the number 0. And plus a and minus a are the same distance from 0. So to solve an absolute value equation, we're going to do the following. We're going to write the two equations obtained by using this fact here, and then you're going to solve each equation individually. A solution to either equation is a solution to the given problem. So here, we're solving the absolute value of x is equal to x squared. This is a very friendly, very low level kind of problem here. Not going to get too complicated with these. So we're going to write the two equations obtained by using this fact right here. We have the x inside of our square root. So this is going to turn into x equals x squared, or minus x is equal to x squared. So now we're going to work with each of these equations individually yet simultaneously, and we're going to solve these guys. So x equals x squared. I would subtract the x from both sides to give me x squared minus x equals 0. The minus x equals x squared, I'm going to add x onto both sides and get x squared plus x is equal to 0. To factor the x squared minus x, I can pull an x out of each term to give me x times x minus 1. To factor the x squared plus x, pull the factor of x out of each term and get x times x plus 1. We now have two pretty basic, pretty straightforward equations to solve. The first one there, we get the values of 0 and 1. The second one there, we get values of 0 and negative 1. So what are the distinct x values that we come up with when solving these two equations? We get negative 1, 0, and positive 1. Now, if your absolute value equation contained any rationals or any square roots, you would have to take these x values and substitute them back in and see if there are any bad things that come up as a result of plugging them in. If there are if there are fractions involved, the bottom can't be 0. If there are square roots involved, you can't have something being negative inside of your square root. So those are the only two things you would have to check, those are the only things you have to check for those two particular cases. But here, there's no fractions, there's no square roots, so we're good. We know that these are three valid solutions.
So
apparently here I provided a whole bunch of commentary. Unfortunately, I don't remember what I said. Yeah, absolute value equations, key thing is taking the given equation with our absolute value, and when you break it up into two, you then remove the absolute value signs. You should never have an absolute value sign anywhere in your work when you're solving an absolute value equation problem. So these were the four types of equations that we had: polynomial, rational, radical, and absolute. Polynomial and rational being more common than the other ones. Guys, if you have any questions, feel free to reach out to me. Otherwise, take it easy.